terms of the mathematics part of it. So yeah, with that I'll start off. So what exactly is machine learning? So this is basically the main Wikipedia, the Oxford meaning of it. So the use and development of computer systems that are able to learn and adapt without following explicit instructions. And basically they are used to analyze and draw inferences from patterns in data. So now what exactly does this mean? So machine learning is basically that we develop algorithms which can learn and find patterns on their own. So you have a set of data, for example, and you want to find some patterns, that okay, this is sort of an increasing graph, or maybe you want to find out, okay, that this is a sort of decreasing graph that always comes. Or maybe, for example, you just want to see in an image, you want to find an eye. Okay, so an eye of a human, basically. If there's a human face and you want to find an eye, so you want to find that. So that also is a sort of pattern only. So that if you want to find out that where exactly is this eye located, or where are the multiple eyes located in a single image, all of that comes into the machine learning framework. And there are a lot of other things as well. In general, I would say it is basically learning on the computer, the algorithms that you build will learn on their own to find patterns in your data. So by data, I mean basically any sort of data, as I said, like it can be, tables which you build in Excel sheets, or it might be images, it might be text, right? All of that can be. So in text, for example, if you want to find patterns as to what exactly does this text relate to, like, for example, if I give movie reviews, so is it a positive movie review? Is it a negative movie review? That sort of thing. So yeah. So how is it different from traditional programming? So you might be thinking that, okay, machine learning is a separate field and then traditional programming is a separate field. So how is it different from traditional programming? So if you see here in the image, in traditional programming, you first have some amount of data, right? And you code a program to, so that you process that data, and after that program executes and stuff, you get some results. Okay, so that is exactly what happens in traditional programming. For example, if you want to find the maximum of a given array or a set of numbers, then you would have some data given to you. You will write a code so that it can find the maximum value, and you will get a result. Okay, this is normal traditional programming. But for example, if you are not told you need to find the max, you are given some set of numbers, and you are given there is some result which occurs from that set of numbers. Okay, if I am given a set of numbers, set of arrays, and I have a result from that particular array or that particular set of numbers, then you have both of these, data and results, and then you need to find out how can I map that data to that result. So basically, now instead of getting the result, you know the data and you know the results, but you need to find the program which can map that data to that result, right? So that is exactly what machine learning is. You try to find that sort of mapping, or you can say function. So ऐसा समझ लो कि तुम्हारे पास x है and तुम्हारे पास y data points कि there is 3, there is x equal to 3 पे y equal to 5 है, x equal to 4 पे y equal to 6 है, and ऐसी different things है, and you need to find a function which basically maps from x to y. So that exactly is what machine learning is. And why is it beneficial? So क्यों traditional programming से beneficial होती है ये? So a lot of time there are things like, for example, images में you might know this is a cat, this is a dog, ठीक है? But you won't know कि भाई how do I classify this? Like how do I program something that is able to detect that cat in that image or that dog in that image, right? Yeah, यहाँ पे traditional programming you would have the image, but how do you code the program? But in machine learning approach, what you need to do is you need to feed in the data. Okay, these are the images, these are its tags. Okay, this is a dog, this is a cat, and your machine learning approach will basically compute how do you find out that thing, whether it is a dog or it is a cat. So that kind of thing is basically machine learning. And so you would think now that we have gotten the program, like, how is it beneficial for us? Like we already had the data, we already had the results, right? So like we don't need extra results. So why do we need to have the program? So the program is required because data is limited, right? You might have 50 data points, 50 sets of data, 50 points of data, and you might have 50 results corresponding to that. And now if you are giving another set of point or another data point, this result you don't have, then you would need to find out what is the result. Now if you give a completely different dog image, or if you give a completely different cat image, then you need to find its like what exactly it is, and is it a dog, is it a cat, and how can you do that? You can do it using this program basically. So if you have this program, you can basically predict, okay, this is a dog, this is a cat, and given any image in the world, you can predict, okay, this is a dog, this is a cat. So just by looking at a few data points or a few images of dogs and cats, you are able to make a program which is able to classify any dog or cat in the entire world, any image of that. So that's exactly what it is. So here I've written train, then predict. So basically this is called the training procedure, wherein you train your program key, so that once you train your program, it is able to perform very well in the real world. And then basically when you ever get a new real world image, you are able to predict on it. Okay. So that is, and yeah, so a lot of times what happens is when ML engineers or ML enthusiasts are working on some problem, they tend to focus on the machine learning approach, and obviously like machine learning is being exploited in very different ways, and it's being used in a lot of different fields. But the other approaches like traditional programming and classical approaches are also pretty good. But obviously some of the traditional programming has its own drawbacks, machine learning has its own drawbacks. So you need to understand when to use what. But yeah, since this event is related to machine learning, we'll have problem statements which will be related to machine learning and not traditional programming. So yeah. But in general, if you have a problem, then just don't go to directly to the machine learning approach. Think about traditional programming solutions, and then if you want to get better solutions, you can go to machine learning approach. So yeah. So now a lot of you would be thinking like, how is this related to artificial intelligence? How is it related to deep learning, which is the exact event that you're focusing on? So this is basically the timeline of artificial intelligence, machine learning, and deep learning. So initially we developed artificial intelligence, and this is basically any technique which enables computers to mimic human behavior. So if, for example, even if I use traditional programming to make a computer work in a way which is similar to humans, that is called artificial intelligence, right? But if I don't do that programming and don't enter that program and stuff, and instead I just give it data points, right? Like as I said in the machine learning approach, then the computers learn on their own how to do this kind of stuff. That is called machine learning. And deep learning is basically a subset of machine learning. So later on in further workshops, you will understand about neural networks. So you might have heard about neurons in your brain, right? So that is how a human brain works, by having neurons which are interconnected and they pass information to each other. Okay? So that exactly is what deep learning is based upon. It focuses on neural networks, and using neural networks, they compute and find patterns in data. So this is what exactly is AI, ML, and DL. So I'll give a brief intro to what are types of ML problems. So there are three types of problems. The first is supervised learning. So here you can say that in supervised learning, you have a supervisor, a teacher, to tell you, okay, what is wrong, what is correct. So for example, if a person does something wrong, then the supervisor will tell it, okay, the correct answer is this, right? So for example, let us say you have tried developing a machine learning algorithm, and that model, basically we call a machine learning thing which can predict things, is called a model. So model is given a dog image, right, and it predicts cat. So now the supervisor will tell you that it is a dog and not a cat. Like the image is not a cat, it is a dog. And then next time, okay, the model will understand, okay, so the supervisor told me that this is a dog image and not a cat image. I did it wrong last time, so I need to do it correctly this time. And this way it will learn slowly and slowly. So this is what is supervised learning. Now, unsupervised learning, as the name suggests, there will be no supervisor. Like you won't have anyone to tell you, okay, this is a dog, this is a cat. So for example, you can see here that there are two fruits, apple and watermelon. So what the model needs to do is it needs to classify things. So what, not classify, the more appropriate word would be clustering. So what it does is it sees the similarity in data points. And once it sees the similarity in this data, it says, okay, all these four things are similar, so I keep them on one side, and all these three things are similar, so I keep them on the other side. So this way, though it has not predicted whether it is an apple or a watermelon, but it has been able to segregate those things into two different parts, right? So now this can be very helpful when, for example, you don't have label data. For example, तुम्हारे पास बहुत सारी images है apple की, and you have a lot of images of watermelon, but you don't want to label them. So the amount of time that it requires to label them manually, you see the photo, you see, okay, that this is an apple, you label it apple, then you see a watermelon, you label it a watermelon. So that kind of thing can be very, expensive, and, it can take a lot of time. So that kind of thing, to avoid that kind of thing, what we do is you can use unsupervised learning to basically segregate everything. in different groups, and then we can just assign, okay, this group is basically apple, this entire group is apple, this entire group is watermelon, this entire group is something else. So that way, this is called unsupervised learning, and basically they learn similarities between data points. Now, reinforcement learning. So reinforcement learning is a type of ML problem which is particularly related to how humans learn. So they learn by trial and error. So you try, the model tries, it fails, it tries again, and so on. But then how does it know that it has failed or succeeded, right? So the main idea is give it a reward. If it succeeds, it is a very good reward. But if it fails, it is a penalty. So that kind of thing is what we apply in reinforcement learning. And mostly our focus on this event will be on deep learning and computer vision, and on the first subpart, that is supervised learning. So yeah, we will be focusing on the supervised learning aspect of things. Now, applications of ML. So these are a few applications of ML which I will be showcasing. So first is computer vision. So you can see here that computer vision is basically how computers or how humans perceive, and we try to extrapolate it to computers. So you can see a computer is able to detect a notebook, a laptop, glasses, like and an iPhone, a coffee. So all these kind of things, detecting things or maybe classifying things, all that kind of stuff from images is called computer vision. Then natural language processing. So natural language processing is basically when you have some sort of text or, for example, some audio speech, and you want to classify, okay, that this is what the meaning of that speech is, or what is that text, or what does that mean. So that all is covered in natural language processing. Third is data science. So data science, you also have an event, Cassandra. So in that, basically, you have a set of basically data points related to maybe, for example, business analytics or banks and stuff, and you want to predict, for example, some kind of parameter, you can say, what is the predicted price of the stock after some time, or what is the predicted, for example, price of a housing plot or something like that. So that, or what is the probability that a person will not pay his loan back. So that kind of thing is in data science, and you also have a different event for that. And the one of the other things is reinforcement learning. So as I said, so in this you can see there is a Mario which has been trained to play on its own using reinforcement learning. So it basically, initially what it would do is it would try and fail and try again, and then once it does so, it does it a lot of times, it understands, okay, what should be the best kind of thing to do while performing this. So yeah, that's reinforcement learning. Then I'll be so this is the machine learning workflow. तो कुछ नहीं होता है, इसमें रॉ डेटा होता है, जैसे डेटा पॉइंट्स आए, तुमने डेटा को प्री प्रोसेस किया, यू कांट जस्ट सिंपली फीड द डेटा इन. For example, you have an image, yeah, you have text, so you can't just feed it in, you need to first convert it into numbers, right? Because we always work in numbers in machine learning, and then when you convert it into numbers, for example, there might be some invalid numbers कि कहीं भाई तुम्हारा by chance कोई negative value आ गई, या there is sometimes called as not a number, या कोई empty value आ गई where you don't have anything in that. So that kind of thing is done in data pre-processing, and a lot of other stuff as well. So we'll explain to you in detail in the further workshops. And then you iterate over this to basically prepare the entire data set. And obviously it is not a single step process that you just apply something and then you get the data points. You get the data points, you see, okay, this is not exactly what I wanted, you reiterate your pre-processing process and so on. So this is the data generation process or the data pre-processing pipeline. Then you have the machine learning framework, wherein basically you have algorithms which you apply, and then so model is basically what models your machine learning algorithm. So as I said, model is trained and then you use it to predict something, right? So that is what exactly your model is. It will first get trained on the data points, then it will try to predict something. So that exactly is what we get here. So that is the candidate model. Okay, these are the different candidate models which we can use, and then you choose a model out of those candidate models that will work best for your problem. And this is basically the training process, wherein you train your model and then you get that model and you put it into your application to work as you want. So this is the machine learning workflow. So this is actually a thing that Google has worked on. So you might know about Google Lens, and this is also a sort of computer vision problem only. So yeah. So you can see here that once you use Google Lens to basically see, like, capture an image or something, and maybe, for example, it is written in some different type of language or something, then it can use it to basically translate stuff. So that exactly is what machine learning is, and a lot of companies are now working on computer vision. So yeah. So with this, I guess we have come to the end of the introduction to machine learning. Now we'll be focusing on Python. So before that, yeah, I would say that a lot of people would be working on maybe C++, starting with C and C++, and they would be saying, why don't you do ML in C++, right? But the main reason behind that is, okay, fine, C++ I accept is faster than Python, but Python is easier to understand, right? It has more support for deep learning resources. So all the libraries you would say, TensorFlow, Keras, and all the other libraries which make it easier for you to work on machine learning and deep learning, and you don't have to go into the maths of it. All that is much more supported in Python than in C++. And yeah, so that exactly is the reason why we focus on Python rather than C++. For C++, there are a few libraries like Cafe and stuff, but they aren't very popular, and they don't have much support. So that is why we do it in Python. And yeah, so with that, I guess we'll move to the Python part of the workshop. Yeah, I guess Payal, you can.
Yes, I will share my screen.
Yeah, I guess we have some doubts in the chat.
Doubts in the chat, okay. So yeah, Jishnu, would there be infinite possibilities for the same like we can't find? So yeah, could you explain it? I don't understand what you were trying to ask. Or Tarun, if you could.
Yeah, it's like you told there are like you give data and results, right? So the machine learning tries to learn a mapping from data to results. So there might be like infinite possibilities, but how do we choose the correct one? Is something like that, I guess.
Okay, yeah. So there can be like, so that is the thing, like, so only a sort of mapping would result in a particular result, right? Like there might be different variations, or there might be different variations. Like for example, so we don't exactly find the source code. So it's sort of like a function or a mapping, you can say. And there might be different functions with, say, for example, different parameters, which might lead to the same results, nearly the same result. So yeah, there can be infinite possibilities, but in general, we try to get to the best possible thing which can be there. So we try to find, okay, what so when you predict things, you try to find that what is the best prediction, which model gives you the best prediction, and that is the exact thing that you come to.
Yeah, so we are not learning source code. We are like learning weights, and we use gradient descent. So it narrows down the weights possibilities. We'll learn that more in depth, I guess, in future workshops.
And NLP, so yeah, NLP is not exactly related to computer vision, but for example, right now, if you see vision transformers, so transformers is basically a concept of natural language processing, and vision transformers is basically using those concepts of NLP in computer vision for better, for better model architectures and for better results. So yeah, and a lot of things like, for example, image captioning are related to, first you capture the features from an image using computer vision, then you put it into NLP, and then natural language processing, and then you, yeah, get the caption. So yeah. Yeah, I guess Payal, you can start then if you don't have any other doubts.
Is my screen visible?
Yeah.
Okay.
Yes.
So hello everyone, I'm Payal Pote, Electronics Part 3. So I will be discussing the basics of Python programming. Right now, many of the first yearites might be having a question that we are learning C right now. Then why use Python? There are plenty of languages such as C, C++. People are also using C++, R, etc. for machine learning, as they have the libraries required. But Python is something that most of us will prefer. Like uh, you won't be able to do much in C or C++. One of the main reason we will be using Python is it's the ease of programming Python provides, and also it has plenty of libraries which are such as NumPy, Pandas, that we will be discussing in this workshop only. This will help you to understand the power of Python and why Python is best fit for ML. If you try to code something uh, any code in the C, it will take around 8 to 10 lines, but the same code will, you can do the same code in just 2 lines in Python. Hello? Hello?
Yeah. You're
Yes,
audible.
okay. Okay. So I will be discussing the Python basics, and like the syntax and stuffs are very easy. Like it's just quite English-like. It won't be hard for you. Like it won't be necessary to go through whole Python documentation at once, but if you know the basics of any programming language, it will be easy for you to shift to any other programming language. Like just go through the basics. I'm gonna tell you now. It will be enough. Okay, so for downloading Python ID, etc., we will be providing links later after the workshop is done. So, okay. So while installing, some of you might get confused between Python 2 and Python 3. Like, so I will be telling you some differences and why we are going to prefer Python 3 over Python 2. As you can see, Python 2 is legacy and Python 3 is a future. Like, what I mean to say is Python 2 is definitely more stable, and many of the web developers are. But for ML purpose, we will be using Python 3, and the reason to it is nowadays many developers are creating libraries which are only supported in Python 2, and they are not compatible with Python. Sorry, which are only supported in Python 3, and they are not compatible with Python 2. So this is the main reason why we will be preferring Python 3. The next one is there is a better Unicode support in Python 3. The next reason is the next feature difference is Python 3 has improved integer division. What I mean by this is if you like say if you divide 5 by 2 in Python 2, it will give you output as only 2. Like it won't give the fractional part, but if you divide the if you write the same code in Python 3, it will give exactly 2.5. Okay. Uh, and the last difference is that they both have different print statement syntaxes. Like you have to provide parentheses in if you want to print something, you have to provide parentheses in Python 3, and which is not necessary in Python 2. Okay, so these are some a significant amount of differences, because of which we recommend you to go with the Python 3. Okay, so now we will start with the basics. So first of all, like I will try to compare this syntax with C, so it would be easy for you to understand. Uh, so first of all, I will okay. So let's start with variables. Like just like C, there are different data types like integer, float, and complex numbers in Python. And Python, like okay, so let's go to syntax. Like there's no need of declaration, just like C. Like you have to define whether the variable defined. You have to define whether the variable is int, float before assigning the value, but it's not necessary in Python. Like you can just simply assign that value. Like you can see here. Let me run the cell. Like you can see, you can use type function to determine the data type of the variable. Like you can see here, it's showing int. Similarly, you can assign this any float value like 0.445. Okay, so this is showing its float and the value is this. Similarly, it's very easy to assign a complex number. Like there are two methods. Here, the first one, you can directly write the complex number as 1 plus 2j, and it will, like you can see here, the type is complex. Okay, and the another method to define or assign a complex number is you can use is equal to complex 1 plus 2. Here 1 is the real part and 2 will be the imaginary part. So it's also will print the same thing. Okay. So as I was saying that Python is very powerful as compared to other languages. Like it provides more features than C. Okay, so it sometimes but don't get overwhelmed. Like there's too many features, and how can I remember them? But there's no need. Like you can always Google it whenever you get stuck, and as you progress with your projects, it will be easier for you to understand like how things work. Okay, so now let's go to the operators in Python. Like they are just similar to C. The first one, like addition, it will just print the addition. Okay. Next one is subtraction. For division, it will be like here, as we are using Python 3, it will print 2.5. Not as I said here, Python has improved integer division, so it will print the exact 2.5 and not just 2. And for floor division, you can use double slash like this. Okay. So here it gave output as 2, which is 5 by 2 is equal to 2.5, but its floor will be 2. Okay. And for exponentiation, we can use the double asterisk mark like this. Okay, so it raised 5 to the power 2. Okay, it printed 25, and the percentage is it will show the remainder. Okay, yeah, so it printed correctly. So this is the only two extra operators here are the double slash, which is floor division, and the exponentiation. Okay, now let's talk about strings. Okay, so in Python we can define string using double quotes or single quotes. Like this is also a string, and we can also define string like this. You just have to assign the string to the variable, and we are good to go. Okay, printed Udyam first. Okay, so like this is the ease of Python. This is the ease that Python programming provides. Okay, as compared to other languages. And if you want to print the length of that string, you can directly use function len, like here. You just have to write print len as like it's similar to English, not much different, but you just have to remember this small function. Now here, like the string is treated as array in Python. Okay, so it also follows zero indexing. Like if you traverse all the characters in the string, you can just use the for loop. This for I. Like see here, it just printed each character one by one. Like it's traversing the whole string, like UD by N. Okay, so you can just, and one more thing, indentation here is very important. Like um, Python does not use any semicolons like to show the end of the statement, or any brackets to show the block of code. And so here indentation is very important. Like if you write it like this, it will give an error, which is expected an indented block. Okay, this is indentation error. So one should remember this error actually. Okay, now the next feature and most powerful feature in is slicing. So slicing is to print any given string. Like suppose you want to print fest. Okay, so you will write so. Okay, you can see here just fest. Like here, phi is indicating the first starting index, which is like for f it's
Payal,
5.
sorry to interrupt you, but
Okay.
they are saying that your voice is cracking. So you can please turn off your video, and it would help. It would help improving the audio quality, right?
Yeah. Okay. Should I start again from looping, or it's
Yeah,
fine?
you can just repeat that part.
Okay. I will repeat it again. Start from beginning. Like Python provides uh, like very so Python is very easy. Like if you want to define a string, you can just assign it to the any variable, and you are good to go. Okay, like strings in Python, we are defining. Hello, shit. Hello,
Yeah, you're audible.
hello. Yeah, okay. So if you like, you just have to assign string to the variable, and you are good to go. Like you can print the string here just like this. Now, if you want to find out the length of string, you can just use function length. You understand the Python, okay? Like you can see it printed 9, which is the length of the string. Okay. Now let's go to the another feature, which is looping. Like if you want to traverse over this whole string, you can just use a for loop, like for I. So you can see we are traversing over each character here. You can see here, okay. Now the next more important feature and most powerful feature here is slicing. Like if you want to print this access in this substring, like if you want to print in this string, all you have to do is just print as 5 to 9. Here 5 indicates the starting index, okay. This is 5 is the index of f, okay, and 9 is showing the end index, which is like here you can see t is having index 8 plus like we have to write this starting index plus n plus 1, okay. So here you can see it will print just first. Now coming to the next feature, like if you want to see if any substring is present in a given string, you can just check it like this. It will just print a boolean whether if the string substring is present in the string, it will print true. Otherwise, it will print false. Which you can see it's printing true. Okay. Now next we can use negative indexing in Python. What I mean by negative indexing, but for negative indexing, it will start from the last. Like T will have the index -1, S will -2, E will have -3 index, and so on. Okay, like you can see here, if I write, it will print T, which is the last character. Okay, like negative indexing don't start. So so this is how it works. And if you want, suppose you want to print elements alternate, like you have to use either num. Okay, so here we have another. We can add one extra value, which is step. Okay, like suppose here I will write 0, which is start index, system end index, and then here's the step. Okay, 2. So it will print printed the alternate character. Okay, like you can define you can have whatever step you want. Like if I take it as 3. Okay, so and if you want to print the string in reverse, okay, here we can use the step as -1. Like it will print the string in reverse. Don't worry, we will be sharing this notebook after the workshop. It will be easy for you. And okay, now let's we move on to the condition statement. I guess you have learned if else in the writers colon after every if else or elif statement, and in C we use else if. Here we just have to write elif, which elif keyword, like you don't have to write else if. Okay, so here if a is equal to 1, it will print 1, otherwise it will print none. Like you can see, it will print 1. Okay, yeah. So if you want to learn about else if statement, I will tell you. Okay, so as soon as the condition under in elif gets the code will stop running. Like it will not execute the next line. Like here, a is not 3, so it will go to the elif statement, and as a is equal to a is equal to 1 and b is equal to, it will print both, and it won't execute the next lines. Like you can see here, it will print both. Okay, so as soon as we hit the true condition in elif, it will not execute the next lines. Like here also a is equal to 1, so many of you might be thinking that it should print 1 also, but no, it stops executing the code here only. Okay, so this is all about if else and elif. Okay, now we will be moving to the built-in data types in Python. Okay, so first one is list. So just like it is just like array in C, but only difference is we can have like it stores the data. It can store data of different data types, like you can see here. And one more thing, we use square bracket to define the list. Okay, like you can see here, it's also having string, integer, float, and other integers. Okay, like there are these are different data types, right? So and one more thing, list also is a order data type. What I mean by this, like it follows zero indexing, and you can reference any element using just indexes. Like here, okay, printed the list. Okay. Like if you want to print the first element, which is cat, you can use like now. As with slicing, if you want to print just CA in that string, so you can write it like this, like okay. This 0 will reference to the first element, which is cat, and this is the slicing part. Like it will print only CA. So yeah, this is how the indexing works here. So if you want to add any value to the list, you can use function append. Like it's just like push back, so it will just append the value to the list, like you can see here. It appended it. If you want to insert any add any element to a particular position, then you can use the function insert. Like here, the first argument will tell the position where we have to insert the element, and this is the value we are going to insert. Okay, so here, as you can see, it inserted p at the index 2. Okay, yeah. Want to remove the element or pop any element from that, like you can just simply use l.pop. Here it will pop only 2. Yes, so you can see 2 is not there. And if you want to remove a particular element, you can use l.remove. So it removed 0.5. Yeah. Now some interesting features I'm gonna tell you. List. If you want to print the maximum list, so you can directly use max function. And if you want to print the sum, you can use the sum function. Like here you can see this. So it gave the max as 5.6, true, and the sum is 10.8. You can also find the count of any element in the list using function count. Like if you want to find the count of 2 in list L, so you can just print L count, okay, which is 2. Like there are 2 twos in the list, okay. So yeah, so we can easily sort the list using sort function. See, it sorted it in increasing order. So I guess this is all about list. Next, we will move on to tuple. So tuple is and one more thing, lists are mutable. Like you can change any value using, sorry, like if you want to change the first element to something, okay, not clear. So it will just yeah. So we change the first element, like they are mutable. Now let's move on to the list, tuples. Okay, so tuple is basically immutable list. Like you can't change change the element. Like you can't even though they are ordered, you can't just change any element in the tuple. So for defining tuple, you can use parentheses. Like one should note the brackets I'm using for each data type. Like for list, it's square bracket, and for tuple, it's a parenthesis. Here you can see. Even though if you don't use the parentheses, it will still be the tuple only. Like here you can see. So yeah, it's still a tuple. So this is the extra feature. And if you try to change any value, so it will give an error. Like here, if I try to change the first element to 4, it will give an error that tuple object does not support the item assignment. Okay, so you just can't assign any or change any value in tuple. Well, I want to show one interesting feature here. Like if I change this element to a list, okay. So if you try to change, like 1 second. So maybe I can. It will not give an error, like you can see here. It didn't give any error. So why is this happening? Like as I told you, lists are mutable, but tuples are not. Here I am changing the list element, not the tuple element. So that's why it didn't give any error. Okay. So yeah, like and one might think that why, like we have list, then why we want tuple? Like there's no need, but actually it's better in terms of memory. Like tuple size of tuple is less compared to the list size, and also it provides fast traversal, and we can't mutate any as it's immutable, so it also provides a fast traversal. Yeah, so this is all about tuple. Next we will move on to dictionary. Okay, so dictionary, if you have used C++, it's you can find that it's equivalent to maps. Okay, like dictionary stores data in terms of key value pairs. Like here you can see these are the keys. Okay, like Joey, Monica, Ross, Rachel. These are the key values, and the 1, 2, 3, 4 are the corresponding values. Okay, like if you here you can see like it will print. If you want to access any value corresponding to any key, you can simply write it like you can print one. Also, another method is write it like this. You can use gate function here. Okay. Suppose if the key we are searching is not present there, like this, the key is not present. This will give an error. But in case of if we use gate function and do the same thing, like if the key is not present here, then it will simply return none. Like it will print none here. So this is a small difference. Okay. And as dictionaries are mutable, you can change any value. Like okay. So here you can see the value of key joy is changed to 32. Yeah. So this is, and now the next and fourth and last data type I will be discussing is set. Like it's similar to set in C++. As I written here, like sets are unordered. And one more thing, dictionaries are also unordered. Like there is no fixed order here. For set, no duplicates are present. Like if you print this set, you can see that it just printed each element once only. Like it will not print other occurrences of that element. And for defining set, we can use curly braces. So you should remember, like for set it's curly braces, dictionary also curly braces, and here for tuple it's parenthesis, and for list it's a square bracket. Okay. So here, I have written here that each element is unique and immutable, but set is mutable. What I mean by this is, since the set is unordered, you can't just reference any element here. Like you can't just for accessing this two, you just can't write A1. Okay, like it will give an error. But so that's why each element is unique and immutable, but set is mutable. Like you can add extra elements to that set just using add function. Like here, you can see it has uh, 6 is added here. And if you want to remove any particular element, you can use discard function. Yeah, so 2 has been removed. Okay, and also you can use remove function here with both these both function will work for removing element. So yeah, like after the workshop, try to revise this thing. Like these are very easy and simple syntaxes, and it won't take much time. So that this is all from my side. And now Tarun and Rishabh will be telling you about the Python libraries. Like one would ask why there's a need of Python libraries, but as I have defined various data types, but they are not enough, because libraries we will be talking about are used for pre-processing of data in machine learning. Like you just can't traverse through 3D data using nested loops, or if you want to visualize data and how your model is working, then, and also if you want to read any CSV files, just these data types are not enough, and like there we will use libraries such as NumPy, Pandas, Matplotlib, etc. So over to you, Tarun.
Yeah, there are some questions in the chat.
Yeah, like for scanf we have input like function. Friends one. Yeah, I'm aware. Why it's not printing two times here? In Janvi, are you talking about sit or
Yes, I am talking about the set.
like each element in the set is unique. Like even if write three many times, it will print only once. Like you have learned sets, I guess, but it will
Got
like
it.
there are no duplicates in it. Like for list, it will print two times three. Like that, but inside it will print only once.
I got it. Okay.
Okay. No, every element is not unique in tuple. Like you can have different, like many occurrences of same element. Yeah, you can add different data types in set. Yeah, memory starts from 0 and okay. I guess you, Sharon, you can.
Yeah, thanks. Is my screen visible?
Yes.
Yeah. Okay, so we'll be discussing our first Python package. This is called NumPy. Actually, NumPy is an open source Python library where we uses mathematical and scientific functions to perform operations on arrays and matrices in specific. So some of the examples of the arrays you can see in this images are 1D, 2D, and 3D arrays. And you already learned earlier that Python has its own array, which is known as a list. So why do we need another package called NumPy? So the main difference is the list can contain different elements of different data types, but in a NumPy array, all the elements are homogeneous. And NumPy is much faster and much more efficient than list because it has much less memory footprint, and also that the elements in the NumPy arrays are continuous in memory location, so it's easier to access them. So this is a code in which you can convert a Python list into a array. So just called NumPy here. NumPy, you can see we have imported it as NP, so it prevents us from typing the whole NumPy. So it's just a brief shortcut, I guess. Um, so to convert a list into NumPy array, you just call np.array and you pass the list name, the list object, and then you specify the data type. So here it will be an integer. And to create an NumPy array, so if you want to create an array of all zeros, let's say of size 2 cross 2, then you just call np.zeros and you just pass the size of the array. The syntax also you can pass the data type, but by default it will be float. And to create an array of all ones, it's the same, but you just pass it as np.ones and you just pass the size. To create an array which has neither 0 nor 1, like let's say it must be filled with 7, so you just call np.full, pass the size and the constant which needs to be filled. NumPy also has different attributes, like if you want to access the shape of the array, then you can call the object dot shape and that will return the size of the array. This will be a 2 cross 3 array. And as you've learned earlier in Python, the indexing of array starts with 0. And you can also have negative indexing, which will be starting from the last element. So -1 will be the last element and so on and so forth. So in NumPy also you can access the same way as you've done in list. Like if you want to access the 8th element, then you just pass 7, and this -3 will be the same equivalent if the size of the array is 10. And as earlier you have learned, you can also use to get a subset of a list. So if you want uh, a subset from starting with index 0, which goes up to index 5, but it does not include the fifth index, so it will be 0, 1, 2, 3, and 4. And the same, you can use a negative index to come from the end of the array. Yes, so NumPy has all these basic mathematical functions which list does not give you. So it might be either to add, subtract, or multiply. And it also has some trigonometrical functions, all of the trigonometric functions actually. Like they'll be showing you some examples like sine and cosine, which Python list does not support. Yeah, NumPy also has some statistical functions. You will be learning more about them in Cassandra workshop, I guess, because it is more related to data science. So to give you an example, it would be mean, median, average, standard
Tarun?
deviation, and variance. Yeah.
Sorry for interrupting. Can you just reduce the speed? You are going too fast.
Okay.
Yeah, this goes slow.
Wait, if you have any doubts, I'll just take it now. You have any doubts which I need to take it now itself, or any topic which I need to do it again? Okay, I'll just take it as a no. Yeah, so NumPy is just an extension of list where you have the elements are of the same data type, and it provides you some inbuilt functions like array, mean, median, average, and you can like plot using trigonometrical functions, cosine, sine, etc. And it also supports the default functions which are there in list like indexing, slicing, and yeah, and some of the ways you can create a NumPy array will be like generally. So if you want a matrix filled with zeros, you can just call np dot zeros, and if you want a matrix filled with ones, so you call np dot ones, and if you want a matrix filled with a constant number, let's say 7, so we just call np dot full, and we just pass the size and the constant which needs to be filled. Yeah, that's it. And NumPy is much more efficient and faster than your traditional list. Okay, so we'll also be talking about tenses. So our next workshop should be teaching you about implementing these machine learning algorithms in PyTorch. And PyTorch uses tensors instead of NumPy. How Python uses NumPy, PyTorch actually uses this default data structure which is tensors. All the inputs and the output which the PyTorch model returns will be in tensors. So it's important for us to learn what those are. So the similarities between NumPy and tensors are both are these multi-dimensional arrays, except that the tensor can run on GPUs, whereas your NumPy cannot run. This is actually a major advantage because when you try to train a model on GPU, actually it runs much more faster and it trains a lot quicker than your traditional CPU, because GPUs have the capability of parallelizing the work. Because NumPy does not support running on GPUs, we have to use tensors, and tensors are actually very much optimized to run on GPUs because they're written in CUDA, so it runs much more faster. So you can actually convert NumPy arrays and tensors interchangeably. So if you want to just convert a list into a tensor, then you just call torch.tensor and pass the object of the list. And the same thing will be done with a NumPy array. So instead of calling torch.tensor, you just call torch.from NumPy and just pass the object name in the so it runs the same thing. Yeah, so you can see both are tensors over here. And I already specified that you can actually place a tensor either on a CPU or on a GPU. Like if you think the device supports GPU or like CUDA, then you can place the tensor on the GPU, and it runs much more, it executes much more faster. Yeah, so you can see here the first tensor was on a CPU, and then we placed it on a CPU which has index 0. And as specified earlier, you can like interchange and use tensor and NumPy. So if you think like if you create a tensor of all ones, then you can just convert into a NumPy array just by calling t.numpy, and the thing will be just converted into a NumPy array. One drawback here is because this tensor and NumPy array share the same memory location. If you change any one, then the other also gets changed. So here, if I just change the tensor, you can see even the NumPy array gets changed automatically. And we can do the same thing with a NumPy array also. Like if you have a NumPy array, then you can just convert it to a tensor by just calling from NumPy, and it'll get converted. And here also the same thing. If you change the NumPy array, then because they share the same memory location, even the tensor gets automatically changed. Yeah. If you want to change a NumPy array or a tensor into a NumPy array, you should remember that the tensor must live on the CPU, because NumPy array cannot be on the GPU. So as they need to share the same memory location, so both tensor and NumPy array must be on CPU. And now I'll take if you have any doubts. Yeah, I guess
भैया
doubts are answered. Yeah.
टेंसर जो है वो बाय डिफॉल्ट सीपीयू पे होता है कि जीपीयू पे?
By default, it's on CPU.
ओके भैया.
Yeah, JAX is also another NumPy equivalent which can run on GPU as well. Yeah, if you have any, if you don't have any other doubts, I guess we can move on to Pandas.
Is my screen visible?
Yeah. It's visible.
Okay. So hello everyone, this is Dishavar and I will be introducing you to this Pandas libraries. So let us begin. So yes, it was created by McKinney in 2008 and is an open source project. And later we are going to look how we can use Python to manipulate our data or clean or query our data using Pandas toolkit. So let's just have a look at that also. So yeah, in machine learning for training an ML model, like you need data and thus a container that can keep this data. So like usually we store the data in formats of the tables, like simply rows and columns, and that is not much bigger than that. So if you observe this picture here, it is a table. There are some records associated with the students. This table clearly shows like the personal details of the student. This every row represent the detail of the student, like Javier in Mexico City. These are the personal details of this student Javier. And these columns are nothing but the attributes of their detail, like what is their name, city, these are the attributes. So this is like how we store the data in format of like tables. So, and yes, we will be using Pandas, which provide us many tools to access, modify, filter the data, and also helps us to visualize the data in forms of different plots like line plots, bar plots, histogram, etc. So first thing first, we have to first import the library. We can do that using this import pandas as PD. So PD we are using as an alias because whensoever we need to use pandas, we won't be writing pandas everywhere. We can use short form like PD. So wherever we need that, we can use and pandas using this simple PD. So again, after that, we have to read the data file. So what is that data file? Let me first show you what is it. So this is a data file records. Like here you can see the first row is for the column names like title, year, genre, duration. These are the attributes of the data set. If you carefully observe that this data set is of movies, like in which year that movie was premiered, what is the title of the movie, genre, duration, rating, director, etc. So this is a data set of ours, like in format of the table. Here it is in .csv file. So this is the data set, like this what Men in Black 2. This is the movie, and there are a lot of the movies. So firstly, what we need to do is to import this data set into our Jupyter notebook, on this Colab notebook. So we can do that using this simple syntax like pd.read csv. It will read the file provided the path of that file. So my file is located here. Let me show you. It is not happening. So anyways, there is a location where the my path, my file is stored. So what I need to just copy the path from there of the file and paste between these brackets. So that will enough for loading this data file. And in this PD pandas will we read that file into a data frame, and we are storing it in df variable. So yes, we can. Okay. Let's just run this cell. So now this data frame has been loaded and it is stored in this df variable. So let's have a look at this data frame. We can usually do that using this dot head method. So yes, by default it displays the top 5 rows of the R data frame. So here these are the top 5 rows. What is it? This is movie and all. So if you want less or more rows to display, you can just simply input the number in between these brackets and then run the cell, you get that. Similar, so head this by default shows you top five rows and the number if you want more in between these brackets. Similarly, this tail method, you have to this will display the bottom 5 rows. So there are these bottom 5 rows, and if you want more or less, just input the number between the brackets and you get that. So this is how you will have a look at your data, and it is always a good practice to like see what is in your data. So next, this df.info, this parameter will help you to learn more about your data frame. So we can just press shift enter to run this cell, and then you will have the info of your data frame, like in what class it belongs. So it is a data frame class, and then this index is they're having this data frame is having 5275 entries, 5275 entries. Index ranges from 0 to 5 0 to this 5274, and there are 7 columns here. This 7 columns, and this name, title, year, genre, duration, and with its data type, like year it is of float data type, and this director name is object. So strings are treated as object by pandas, so there is nothing to worry about that. So it is same like strings. So this another thing, this null count. So it is not exactly equal to this 5275 entries, because there are values which are missing, or like here you can see in the original data, there are some values which are missing. So they will be interpreted by pandas as null values. So here some values which are missing will not be here. So we'll be talking about null values after some time. So let's just observe some univariate statistics of our data frame. So let's run this cell first. Using this df.describe method, you can learn about the statistics of your data set. So dot t is nothing but the transpose. So it was looking good, so I just input that. So this year you will have basic statistics like what is the min value of that column, like that year column, what is the min value, what is the max value, standard deviation, and all. This 25% is quartile, so first quartile. 50% is like median, like 50% data is below this point and 50% data is above this point. So these are the random, but like not random, simple statistics of our data set column wise. notice one thing, there are only 4 columns here. Because they are only which are having numerical in nature. Those uh, columns which are of string data types or object data types don't have any statistics. So yes, that makes sense here also. And after that, this df dot column, you can just access what are the names of the columns and display the columns. So there are 7 columns, this title here. So that is also a useful thing to do. So yes, and one thing I told you that we can also visualize the data set using Pandas libraries. So for that we need to select our column, like column wise we'll be visualizing the data. So let's say I am selecting one column. So let's say there is rating column. Okay, so this is how I select. Okay, so this is how you select a particular column. Just input the name within this square brackets. There is another way to access the columns also using dot method. This will also display the same results. However, when there is a space between the name of that column, it won't work this dot method. So it is always a good practice to use this square braces method. Okay. So this is how you can access a particular column. So let's just visualize it. So you can do it simply using pandas. Like you have to just use this dot plot method. So let me show you first. Run this cell. So this is by default a line plot. So line plot is a bit messy here. So let's just try another plot. That is, we can use this kind attribute, or we can have another plot like KDE plot. KDE is a density plot if you don't know about it, so don't bother. Because in Cassandra workshop you will be have this idea of what is KDE density plots. So there are several ways to display your data in form of histogram. You can do that, like this is an histogram. Whenever you get stuck, you just Google it or check the documentation, like this here. This is the documentation you will be having. So there, this is one of the kind method. This method. There is having a lot of parameters. This line, you can use line plot, bar plot, horizontal bar plot, plot, etc. So there are different ways to visualize your data. So again, this another cell is for visualizing the data. It is in format of the density plot. Notice this figure is a bit bigger, so you can do that using this fig size argument. It is a tuple where the first value is for width of that image or that diagram, and the second argument is the height. So you can do that also. Change that. So another thing that I want to show you that how we can use Boolean masking. So Boolean masking is an important and powerful technique to query our data once you know how to properly use it. So let me show you how this actually works. So let's say we have this rating column. So let's say we want to filter out all of these rows in our data set, which is having a rating greater than 8.5, like all the movies which are highly rated 8.5 movies. So you can just do that using this greater than sign. So notice this it will show you bitwise operation like false, and those column values which are less will have this false value, and those column values, rating values, have greater 8.5 values, they will be having as true. So once you enclose this mask, this is mask of true or false within these df, then you will get the rows which are having rating greater than 8.5. So all these movies are having rating greater than 8.5. So this is one of the Boolean masking you can do. So another thing, let's say you want to filtering your data based on multiple columns. So how you can do that? Like I want all the movies which are of genre horror and must be premiered in 2018, let's say. So we can just do that using this, like selecting this genre equals to horror, and this df dot what do we have here? year equals 2018. You have to first enclose these things into brackets, otherwise you will get an error. So df dot. So this is how the rows which are having genre horror and released in 2018 will be filtered out. So all these movies are filtered out. So this is typically bit by this Boolean masking. So you can just play with these values and get a better understanding. Anyways, let's move further. So I told you there are some missing values in our data set. So there are some ways to treat the missing values, like firstly we will be seeing is there any null value in our data set. So using this syntax of df.isAny, you can have the null values in like column wise. So this title is having two values missing, year 7 and so on. So there are multiple ways that you can treat these null values. Like you can replace it with mean, median, mode, and these things. So that all will you will be learning in Cassandra's workshop. So one thing at that I want to say that if you are participating in Mosaic, then do check for this Cassandra, because by checking these two Mosaic and Cassandra events, you will have a better understanding of machine learning. So anyways, so this is here we are just going to drop the null values. So we'll be first checking what is the shape of our data frame. So originally these were the rows in our data frame and 7 were the columns. So now for treating the null values here, we are going to just drop these null values. So you can do this using this df.drop_any. So notice there are some different methods like access, how HOW method. So access 0, what is it? So access 0 is for row wise dropping. So any value which is having null, like this value is null here. If I have access as 0, so this whole row will be dropped. So that is what I want to say here using this access 0. And if access is 1, then this whole column will be dropped. Okay. So there are different methods to do also that, like how HOW method, any. If any of the row has having any of the value is missing, then it will drop that. And if you have selected HOW as all, then if a particular row is having all the values as null, then only it will be dropped. Otherwise, it won't be. So we can just select access as 0, and we can HOW is by default, this is any. So this will drop your, okay, this is, so yes, these values are, those null values are here dropped. Notice there are some values as 5,223. Previously there were some more values. So those are the values which are having any null value are dropped here. So originally it hasn't been any change in the original data frame. So for that you have to make this in place argument as true. Now it will display the change in the original data frame. So you can check, counter check if there are null values or not. So yes, there are no null values because we have dropped them. And this is the updated size of the data frame. There are some values has been dropped here. So again, let's say if you want to drop some of the columns, so you can do that also with drop any. But here you have to select access as 1 because it will be column wise dropping. So you have to drop a column and you have to input the name between these brackets. So if you want to drop any row, any column, right? It is going. Do you have drop? Select your row that you want to drop. Title is the row and it is of axis 1. Why this is showing me error?
Yeah, Rishabh, can you define what's axis once more if they have a doubt?
Axis is like row. There are two values only for axis. If zero is for row wise dropping. If you want to drop a row, then you can have axis as 0. If you want to drop a column, the whole column, then you have to access that value as 1. So here I will select first any row, any column. Why it is showing me an error? Axis is here. Again, it is showing me an error. I don't know why it is. But usually this is the syntax that should work. So let me do one thing. Just do here the same thing. Okay, I got that why it is showing me the error. So you have to just select first column, then okay, drop. Drop is the method that will help you to dropping any column. So here you can just simply run this. It is access also you have to mention. 1. So now it is fine, correctly working. So the genre that was the originally a column is here dropped. So this is the way you can drop multiple columns. So title is, let's say I want to delete one more column. So you can do that using this. So these changes will not be reflected in original data frame. So for that you have to first make this in place value as true. So now you can cross check using df. So there are now 5 columns, 2 we have dropped. And lastly, I want to tell you like how we can save our data frame as a CSV file. So if you make a model which is used for predicting someone, then you have to save your predictions as CSV file. So for that, I'll be telling how to do that. So firstly, let's just create a data frame. So let me make some columns. So you can do that like this np.arrange method. Let me first run the code and show you. Np it is not imported. Okay. So this is np.arrange. This is one vector. This is the arrange is the method that you can use. Like this first was the starting value, and the last one is the ending value. This is exclusive. This won't be in your array. So and this third argument is the step that you want to take. So here we will be starting from 0, then ending, and then up to 100, and we have the step size as 2. So this is the result that we have. So let's just create another column, let's say np dot sign of this first column. It is, so let me show you. So this is again, you can use a sign function for having the sign values of that first column. So that is another column, and let's say another column that I want to form. It's random dot rand 50 values. So it will show you 50 values within 0 to 1. So any random values it will generate for, within 0 to 1. 0 is inclusive and 1 is exclusive. So it will generate any 50 values within this 0 to 1 range. So now we have these three columns. So let's just make one data frame first. So you can do that using pd dot data frame. And then you have to put the names, like I will be naming them feature 1, feature 2, and there are three columns that I want to have in our data frame. So this is the names and the columns that I have. C1 is the column, C2 is the column, C3 is the column. So this is the syntax that you have to use to convert it, these columns into a data frame, like in form of a table. So you can just store that in a variable called data, and then you can have a look at that head of it. Pandas. Okay. Syntax errors that you will see. So now it is fine. So this is showing like what the data frame you have created just. So now this data frame is having 50 values. So now I will tell you how to store it. So you have to just first type the name. What is the name of our data frame? It is data. Then to CSV, and then the file name that you want. So let's say I want to store it as a data.csv file. So yes, this will be stored, and you have to like provide the path. So using / method, you can save this data in the same file as your notebook is in the same folder. Like in this data CSV file has been saved, you can just download and check that. So this is how you will save your data frame, and you will like download it. So one thing that I want also you to consider. So here first column is for the features, and this first row will be for the indexes. So sometimes we don't want this indexing to be true. So there are certain arguments that we need to change. For index, we have to make it false. And just run this cell, it will save the data frame. It will override the previously stored data frame. You can download and cross check now. So yes, the indexing has been gone. So this is something that you have to do when you will submit your some prediction in format of a CSV file. So this is very interesting to do. So yeah, that's it from our side, and if you have any doubts, you are most welcome. Okay, is there any doubt? Just
Yeah, guys, if
It's
you have any doubt or
A-R-A,
stuff,
not A-R-R. Ritesh Lagara.
so there are and operation.
अरे
There are
हाँ डबल आर नहीं सिंगल आर
Hello, Ritesh. It's arrange. A-R-A-N-G.
arrange, ARANG, arrange. Let me show you where it was. So again, and ampersand is a bitwise operation. There are multiple operation that you can do, like you can and or maybe a lot of things there are. So you can experiment it by yourself. It is like in C++ or C we uses double, like doubles of ampersand, double of slash signs for. But here in Python you is using only single one. That is equivalent to bitwise operators here. And axis has only having two values. Either it will be 0 or 1. If you want to drop a row, then you have to select axis as 0. That means row wise dropping. And if you want to drop a column, then you have to select axis as 1. That will help you in dropping a column. In place do so the changes that you will be doing in your data frame won't be truly reflected in your original data frame unless you will make this in place argument as true. If it is false, then it will show you how the changes will look like. It won't be saved in original data frame. So if you make this in place argument as true, then the changes that you have made will be reflected in your original data frame. That wasn't out. Okay. Okay. So okay. Any other doubts? Yes, everything will be shared to you. PPT and notebooks will be shared to you here in the team itself.
You can check the file section, like we will upload everything.
Yes, we'll upload the data set and the notebooks and all. So yes, that's it from our side.
Another, like, if you could, like, if anyone thought it was maybe too much to understand in the first workshop, so we can understand ऐसा हो सकता है. So I would suggest you go through the notebooks, you go through whatever slides we have shown you today, and recording भी है YouTube पे, and last year की भी है, but like दोनों similar ही हैं, तो like देख लो, and once you do that, so you would be able to understand and keep on working, on this. So we might be giving assignments and stuff before the next workshop on the NumPy, Pandas and stuff. So make sure you properly read all these things and explore as much as you can.
Thanks a lot, Mosaic coordinators. That was a really informative session. I have shared a Google form link in the chat. So I want you guys to fill this form up. And this is basically an anonymous feedback form wherein you would be telling us about what did you feel about the workshop, how much did you understand. Please help us know about your views, and this would help us to improve the future workshops. Thanks a lot. This is all for now. You may leave the meeting. Please fill in the Google Forms.